Hey there, this is Math 7, Unit 2, Lesson 8, Comparing Relationships with Equations. So you began today's lesson looking at a shape like this, or an image like this, to kind of talk about patterns with some rectangles. You might have noticed, for example, that this one had a length of 3 and a height here of 1. This one went from 6 to 2. This guy went from 9 across to 3. And things you might have noticed, this is increasing by 1 each time all the way up. Or you could also take a look and say from here to here it's a times 2, and here to here it's a times 3. And if we look here, to go from 3 to 6 is also times 2. To go from 3 to 9 is a times 3. So we can see there's a relationship definitely happening there. We can also just notice, just from addition principles, this is plus 1, this is plus 3, all the way down. If you were to talk about perhaps the area of this shape is 3, the area of this shape is 12, and the area of this shape is 27. So the area is changing as you go along. So there's lots of things you can look at with these shapes as you're talking about the patterns. You probably could predict which shape might come next and what that would look like there. So that's how you opened up today's math conversation. So when we go to part 2 of this lesson, it says that we're going to use the equation F equals 9/5 C plus 32. This is a conversion formula to change Fahrenheit into Celsius or Celsius into Fahrenheit. And so it's just a formula you plug values into to figure the other one out. So in this case here, they gave us the formula they gave us the temperature in Celsius, and we want to convert that into degrees Fahrenheit. All right, a little bit of a process there, but we can do this. So for 20, we would say that we have 9/5 times the C value, in this case is 20, plus 32. That's what we're going to solve for. Okay, so I can reduce 5 goes into 20 4 times. 9 times 4 is 36, and 36 plus 32 is going to be 68. So 20 degrees Celsius is the same as 60 degrees Fahrenheit. Okay, and we'll do the same thing for the other ones. You take your 9/5, multiply it by 4 plus 32. This one's not quite as pretty, okay? So we have 36 over 5 because there's no way to reduce that there. So that becomes 36 over 5, and then we're going to add that to 32. Now I could convert this first of all. 5 goes into 36 7 times. I'm left with 1 left over, 7 1/5. So let's combine our 7 1/5 and our 32, which would combine together to give us 39 1/5. Okay, so kind of a goofy problem there. So 39 1/5 degrees, or I could say 39.2 if I knew that 1/5 was the same as 0.2. Okay, and then for the last one here, you have 9 over 5 times 175 plus 32. And when you work that math out there, you end up with 347 degrees. Alright, so this seems to be changing. We could take a look at x and y's and decide is there a constant there. But one of the things we're going to notice is that it seems to change in kind of an erratic fashion. And just like that car problem at the park the other day, and then the one with the taxi cab, it's this value right here that's really throwing things off to allow us to not have a constant proportionality. Let's take a look at this one here. This is the equation that will convert centimeters to inches. Okay, notice the value of it looks a lot like our y equals k times x, doesn't it? It's in that same pattern. So we might likely have a proportional relationship. So in this case, when I plug the values in, because I'm going to take the value of the inches times 2.4, I could just write it here, times 2.54 times 2.54 times 2.54. And a 10 times 2.54 is 25.4. 8 times 2.54 becomes 20.32. And 3.5 times 2.54 becomes 8.89. Okay, so in terms of the two relationships, are these proportional relationships? We would say that the Fahrenheit and Celsius one is not, because there's not a K, there's no K value, there's not a constant proportionality that exists in this table. Your Y over your X is always changing, isn't it? Okay, and you could do the little math there to figure that out, but if you were to do 68 over 20 and compare it to 39 over 4, they're not going to be the same. But with your inches and centimeter one, we would definitely say yes it is, because the numbers are changing at a constant rate. And so again, if you did your 25.4 over 10, you'd end up with this as a solution. That's your K value. Your K value is 22.54. It has a constant proportionality. If it doesn't have a constant proportionality, it's not going to be a proportional relationship. And this one does. We would say, yep, it is proportional. From there, you had a conversation looking at some cubes, and you had 3 different charts to complete based upon the information of the cubes. We had a side length given to us, and we were going to compare side lengths and with the edge length, surface area, and volume, all different things. A few things that you probably needed to know ahead of time is that when it comes to edges, right? When it comes to edges, you have to know that on a cube there are going to be 4 edges in the front, 4 edges around the middle, and then 4 edges around the back. There are 12 edges. When it comes to the face or the surface area, okay, so the surface area, you're talking about how many faces there are. 1, 2, 3, 4, 5, 6. And then when it comes to volume, if you recall, is going to be the length times the width times the height. Because these are all going to be cubes, we can say it's the same as the length cubed, because it's the length times length times length in this case here. So that becomes our formula there. A little bit of background knowledge to kind of help you out with what's coming on up. So number 1, how long is the total edge length of each cube? We've already established that for every cube there are 12 edges. So what we're going to do is we're going to multiply each side length times 12 to find the total length. So if I have 12 edges and they're all 3 inches long, or 3 whatever it might be, I end up with 36. If they're all 5 inches, just say inches for now, long, times 12, I end up with 60. 9.5 times 12, I end up with 114. And S times 12 is 12S. If I was to compare this, I could write 36 over 3, and when I reduce that, it becomes 12. I have 60 over 5, and you reduce that, it's 12. I know it's the same thing we just did, how to get there, but I'm showing you that this is a proportional relationship, right? It's set proportionally. Why? Because our total length, so our length, is equal to the value of 12 times the side length, isn't it? Okay, so our length is equal to 12 times the side length. That's how we're getting there. So that's what we have. So let's move over to the next one. What is our next one here? We have side length is 3 times surface area. Well, we said before that for the surface area, to find the surface area, oh, the area is 6. That's the 6 faces. I should have said this here. The surface area, you're going to do your area, which is going to be in this case here, the length times the length, but then we're going to take that value and we're going to multiply it by 6. Okay, so if the side length is 3, then what I'm doing is I'm doing 3 times 3, or 3 squared because it's area, and I'm multiplying that by 6 because there are 6 faces. So 3 times 3 is 9, times 6 is 54, and that's my first answer there. When I look at this one, I'll do 5 squared times 6. 5 times 5 is 25, times 6 is 150. And then 9.5 squared, boy, that's going to be a little bit crazy, huh? 9.5 squared times 6 gives you 541.5. And this one here just becomes the s squared, and then we put, we call it coefficient out in front, 6 faces, 6s squared. When I look over here at this one, the side length becomes a side length cubed. Whatever it is, it's cubed. 3 cubed is 27. 5 cubed is 125. 9.5 cubed is 857 and 3/8. And then this just becomes s cubed. So first of all, not first of all, but number 4 does ask you which one of these relationships is proportional. And we would say that the side length one is the one that is proportional. It's proportional, why? Because our y over x value is the same for each one. It is constant. And again, that's why we call it a constant of proportionality. That's our k value. The other ones, if you divided 54 over 3, 150 over 5, you'd get a different k value. So you don't actually have a k value. You just get a different value every time you find the quotient between your area and your length, or your volume and length is the same thing. They're not going to be the same. So when you write an equation for the total edge length, E, surface area A there, well, our equations will look something like this. To find the edge length is going to be equal to, and we can use our values down here in the table, 12 times the number or the length of the side, 12s. Okay? For the area one's going to be 6 faces times the area of one of those faces. And the volume would be equal to a side length cubed. And only one of these here is in that form of y equals kx, which it needs to be in order to be a proportional relationship. All right, turn the page, looking over here. We're going to skip the are you ready for more, and we're going to move over to the part 4, all kinds of equations. Predict which of these equations represent a proportional relationship. So looking at all of these things here, as I draw a box around it, you can probably take a look at your notes, or if you were absent today, think we want it to be in the form of y equals kx. That's the form we want it to be in. But the other thing that it can look like is it could also be, because k can be a whole number, right? Or it can be the reciprocal. We could also have y equals 1 over k times x. Now the thing is, you often don't write that as y equals 1 over k x. What happens is when this is rewritten, it tends to look like this. Y equals x over k. We're just taking that x and multiplying it by 1 and sticking it on top. So sometimes you could have an equation that looks like this, or most of the time it'll be like this the other way. You usually won't see a fraction in front of the x. If it's a 1, you'll have the x on top. So those are going to work there. So if I take this information and slide back over here, let's take a look. I have 4 plus x, not the same, right? That plus is not going to work for me. Here is one that looks very much like that, so that's most likely to be proportional. Here's 4 over x. Don't get confused. We said the x has to be on the top, so that's the wrong way. Not going to work. Here's x over 4, so that's the same as saying y equals 1/4 x. This one is an exponential one, not going to work. And this one also has x to the 4th, not going to work. Kind of like that volume one, but with the 4th power. Your next activity in class then was, now you predicted, was to complete the tables to prove or validate whether something was going to be a proportional relationship or not. And as you do this, what you're going to discover is you're going to find out that this one certainly is proportional, and this one is also proportional. So if I was to fill in this table here, for example, you're going to just plug things in. So 2 plugged in there becomes 4 times 2. So 4 times 2, which is 8. Now my value for y over x is 8 over 2, which is 4. When I plug the 3 into there, I get 4 times 3 is 12. And then y over x is 12 over 3, which equals 4. When I plug the 4 in there, we get 16, because 4 times 4 is 16. And 16 over 4 reduces to 4. And when I plug the 5 in there, we get 20, and 20 over 5 is equal to 4. So we can see that there is a constant proportionality here working with this equation, and that would definitely be true. We can do the same thing over here. We multiply the number 2 by a fourth, so 2 over 4 reduces to a half, right? 3 over 4 is just 3 over 4. 4 over 4 is 1, and then 5 over 4 is here, 5 fourths. Now I put my y over my x value, or the other way around. This becomes 1/4. Now, when you did this problem, you might have said, y over x. I know I need to do that. That's the same as y divided by x, right? Let's take a look at this fraction one just because it does come up a few times. If I did y divided by x, my y term is 1 over 2 divided by x is 2. Yeah, so that's what I have. Now, when you do this problem, when we talked about dividing a number, we can multiply by the reciprocal. So we could write 1 over 2 times, and the reciprocal of 2 is what? 1 over 2. So 1 over 2 times 1 over 2 is 1 over 4. So that's how I end up with 1/4. You can do that same thing here as well. You're going to have 3/4 there divided by 3. Same thing for this one. So as you work that out, you're going to have to write it out and solve that. But as you go through, you're going to find that all of these values are indeed proportional. They're all going to be 1/4. Just do the work to show that that's going to be true. On these other values here, you're just plugging them in and filling it out. So 4 plus 2 is 6, 3 plus 4 is 7, and when you look at your proportional things here, you have 6 over 2, which is 3, 7 over 3, which is not 3, right? It's 2 1/3, and we're not proportional. Up here, same idea. You have 4 divided by 2, which is 2, and 2 over 2 is 1. And you put a 3 there, you have 4/3. 4/3, and again, if you do the multiplication part there, 4/3 divided by 3 becomes 4/3 times the reciprocal, which becomes 4 over 9. And those are not proportional there, are they? So we'd say nope, nope. And do the same thing for the other ones. 2 squared, or 4 to the second power, is 16. 4 to the third power is 64. If I write 16 over 2, I end up with 8. 64 over 3, I end up with 21 1/3, not proportional. And if I put 2 there, 2 to the fourth power is 16. 3 to the fourth power is 81. Let's look at my y over x value. 16 over 2 is 8. 81 over 3 is 27. And again, not proportional. So I didn't do the other boxes because, again, this is a review of the lesson today. So there we go. Number 3 asks, do these results change your answer to the first question? For us, we would say no, because we're proving that these are indeed the proportional ones. So what do they have in common if they're proportional relationships? What they have in common if they're proportional is they tend to always be, or they're always in this form, y equals kx. They have a constant proportionality that's the same for each one of them, and it never changes, okay? There's nothing added on or put over here, squared, cubed, whatever. It's just that basic block right there. All right, so if two quantities are in a proportional relationship, in summary, then their quotient is always the same, right? That's the y over x value. In this case here, they show it with a's and b's, okay? So if an equation cannot be written in the form y equals kx, and it does not represent a proportional relationship. That's essential to today's lesson. You want to be able to walk away saying, yep, it has to be in the y equals kx form. Just remember that y equals kx can also be y equals x over k. That's the same thing, except now you have a fraction for your k value. That's all right too. Okay, pause there and let's take a moment to look at your homework. All right, for the homework today, we have, first of all, we have a relationship between distance in yards and the same distance in miles described by y equals 1760 m. Notice this looks a lot like a y equals kx type of equation, doesn't it? So most likely we're going to have a proportional relationship. So if the mile value is 1, I'm going to multiply by 1760, and that's going to give me 1760 there. This is my K value that I'm multiplying through. 5 times 1760 is going to get me 8,800 there. Awesome. Now, if I'm going this direction, I'm going to multiply by the reciprocal, 1 over 1760. And so 3520 divided by 1760 gives you 2. And over here, I'll multiply by 1 over 1760 again, and that's going to give you 10. Is there a proportional relationship between the measurements in yards and miles? We would definitely say yes, there is. Now you need to write down why and explain. Again, you're talking about this constant proportionality, that y over x value is always the same when you figure that out. If you do the division there, you end up with a constant proportionality. That's the K value. So talk about your K value, talk about the sameness of the K value, describe that there. Number 2, decide whether or not each equation represents a proportional relationship. Our key thing today was saying it needs to be in the form y equals kx. So here is the remaining length of a 120-inch rope after x inches have been cut off is 120 minus x equals L. 120 minus x equals L. Does that match our proportional relationship equation? It does not. So we would say nope for that one. Total cost T after 8% sales tax is added to item's price. Here we have a constant times a variable equals a variable. That looks a lot like our thing. This looks like kind of like kx equals y. The order doesn't matter so much, but we have the same information, so we would say yes on that one. For letter C, we have x equals m over 4. Okay, this reminds me a lot of our y equals x over k, where k is a fraction. Can I rewrite that 4 as a fraction? Sure. I can write it as x equals 1/4 m. So if it helps you see a little better, this can be rewritten as that, and now we're in that form of a variable equals the constant proportionality times the other variable. So we would say yes on that one. And finally here on D, we have a variable equals a constant and a variable, but this variable is squared, and because it's squared, we would say nope, it's not gonna work. Okay, we're gonna use this next equation, y equals 5 over 2x, to fill in the table. We can already tell this is gonna be proportional. Why? Because there's my y, there's my k, there's my x value. This should be proportional, but let's take a look at what they're asking us to do. So our equation, again, is y equals 5 over 2x. That's the equation we're working with to fill in this table. So when I plug the value of 2 in, you have 5 over 2 times 2, which becomes 10 over 2, which becomes 5. There's that one. For this one, I have 5 over 2 times 3, becomes 15 over 2, which is 7.5, 7.5. And then 5 over 2 times this number 6, so it becomes 30 over 2, which is 15. 15 there. Is there a constant proportionality? To figure that out, we would do 5 divided by 2, which is 2.5. We could do 7.5 divided by 3, which is 2.5. And I could do 15 divided by 6, which is 2.5. Is there a constant proportionality? Yes, there is. And so we can confirm that this is a proportional relationship. For B, we have this equation, y equals 3.2x plus 5. Can you already tell what's going on there? What's the added part that's not supposed to be there if it's proportional? Yep, that's the extra piece right there. That's the part that's going to throw the whole thing off. This is like our fee to get into the park per car. This is like that extra price for just the first mile driving the taxi. That part's going to mess it up. If we didn't have that, we could have a proportional relationship. With that, it's going to mess the whole thing up. So when you plug these values in and you need to show your work, so do your work, so show your work, you should end up with 8.2 there, 11.4 there, and 17.8 there. And then when you look at your constant proportionality, it's 8.2 over 1. Now 11.4 over 2 is the same as 5.7. And so already these are not matching, so we would say, nope, it's not going to be a constant proportionality there, which means it's not a proportional relationship. And finally, moving down to number 4. Okay. We're transmitting internet information, large files broken into packets of smaller sizes. Each packet has 1,500 bytes information. And the equation to relate the packets to bytes is going to be B equals 1500p, where P is packets and B is bytes. Okay, so first one, how many packets would be needed to transmit 30,000 bytes information? So they're giving me the bytes, and I'm trying to find out the P. Part. So if I use my equation they gave me, they started off by saying, well, B equals 1500p, and in this case they told me that there were 30,000 bytes, so I can put that in for B. Instead of equal to 1500p, to get the P by itself, I'll divide both sides by 1500, and 30,000 divided by 1500 is going to be equal to 20. So how many packets is it going to be? 20 packets. 20 packets. For B, it says how much information could be transmitted in 30,000 packets. So now we're talking about the information is the bytes part, right? How many bytes information? So it's B equals, in this case here, 1500 times the packets, which is 30,000. So 1500 times 30,000 is going to equal 45 million bytes information there. The last one here is a little bit interesting because it says that each byte contains 8 bits information. Write an equation to represent the relationship between the number of packets and the number of bits, not bytes, bits, number of bits. Okay, so before our B value, our packet was in terms of like 1500 bytes, right? So we had 1500 bytes before. 1500 was the bytes. But we know that each byte contains 8 bits for a total of 12,000 bits are inside of that. Okay, so I can take this same number and use this to then make my new equation. So whatever I'm trying to solve, if I have 12,000 bits of information times a packet, will tell me the relationship for this value there. Okay, so I don't know what that's going to be, but that's the idea, is I'm just kind of putting the bits and the bytes together, multiplying them, and that becomes my new constant proportionality K. Okay, that's it for today. Have a great day, and we'll see you next time.